So basically, we understood about the differences between the analog signals and that of the digital signals, and then we understood about the concept of multiplexers. Okay, if I am correct, right? Okay, right. So multiplexer we have discussed, and also we have discussed what was called as the demultiplexers. Okay, so these are the things what we have done in the last class. Okay, now just to proceed today. Okay, right. So what we have discussed is multiplexer, okay, which is nothing but a device which is going to be used to send the signals. So it is basically many to one. Then we have discussed what was called as the demultiplexer, which is a device which is going to take one input and send across to the any one of the output. Okay, so that is generally called as one to many. Okay, then we also understood what was called as the data acquisition. Okay, so data acquisition we understood. So that is we call it as DAQ, and then the analog and digital signal. Okay, so this is the up till here we have discussed. Okay, right. Now we'll continue and we'll try to understand. Okay, so what is the subsequent part of this? Okay, now today we'll be understanding about what you mean by analog to digital converter. Okay, that means just make a note: analog to digital converter. Okay, now as we have discussed in the last class, the analog, the many output from the sensors are going to be analog in nature, but that has to be converted into digital so that you can process it by using the microprocessor. Okay, so from the microprocessor you can able to do only what is called as a digital data signal. So therefore requirement is to convert the analog signal to digital signal. The device which is going to be used for that is called as analog to digital converter, and we are also going to call this as what is called as A bar D converter. Okay, so this is an important question from the exam point of view. Just make out this diagram, then we'll have the explanation. Okay, so take this diagram. Right now, now this is nothing but your analog signal. Okay, analog signal is the one which is a continuous function of time. Now this analog signal we have to convert it into what is called as the digital signal. Okay, right. Next point, just make a note. Okay, is that just write this and explain. Okay, right. Now these are called as sampling pulses. These are called as sampling pulses. Then next you write down okay, sampled signal. Okay, the first one was the analog signal, then the sampling pulses, next was the sampled signal, then next is going to be sampled and held signal. Okay, right. Sampled and held signal. So this is going to be like this. Just write the same way what I am writing. I will explain to you. Yeah. Yeah. Try to make out exactly what is that I am writing so that it's easy for me to understand. Okay. Have you noted down? Please note it down neatly. Okay. Over. Noted down?
Yes, sir.
Okay, right. Now, just observe one by one. Okay, now, the first diagram, what is that I wrote is, which is called as an analog signal. So, this is a signal obtained from the sensor. Now, as I told earlier, analog signal is the one which is a continuous function of time. Now, this analog signal, I need to convert this analog signal into corresponding digital signal, which could be processed by using the microprocessor. Okay. Then the second diagram, what it shows is called the sampling pulses. Means what? What do you mean by sampling? Ah, okay, what do you mean by sampling pulses? The sampling pulses is the point at which, okay, is the time at which you want to know what is the magnitude of the analog signal. Okay, please understand. So what is that I'm rewriting on this? No, okay, no, I'm writing on the same thing. Okay, don't just right. What is that I am writing is, so these are all the sampled signal sampling pulses at the different instant of time. That is at time t1, at time t2, at time t3, at time t4, like that. At all this point, you want to know what is the amplitude of the pulse. Okay, right. Now, then next is going to be called as the superimposition of analog signal and that of the digital, sorry, sampling pulses. Are you understanding what I'm meaning? Are you getting the point? Okay.
Yes,
First one was the analog signal, then was the sampling pulses, right? Sampling pulse is the time at which you want to know the right time at which you want to know the analog signals. Okay, right. 1 second, please. Hello? Hello?
Yes, sir.
Yeah, sorry. There's some problem with my laptop. 1 minute. I'm just presenting it. Okay. Okay. Oh. Nothing is visible, no?
It's visible.
Now, what is visible?
Blank page.
Blank page. Okay. Oh, I think whichever I wrote, no, I think as I have not saved, it is not there. Okay. Okay. Right. No problem. Okay. Let me write again. Okay. Now I'm just rewriting that whatever we just wrote. Okay. Right. Now. Shit. One second. Okay, right. Okay, now I'm just rewriting. Now observe. Now this is going to be what is called as the analog signal. What you are going to get. Okay, first one. Okay, right. Now this analog signal has to be converted into digital signal. For that, what is that I am doing is in this particular instant of time. We are going to take the amplitude of this signal at a particular time. So that time at which you want to know the amplitude is called as the sampling pulses. Okay, now I need to generate a sampling pulses. Okay, now these are all the sampling pulses generated. That means what this pulses indicates that these are all the time period at which you want to know the amplitude of the analog signal. Okay, amplitude of the analog signal. Okay, so this is called as the sampling pulses. Okay, right. Now I am superimposing what is called as your analog signal. Please observe, superimposing the analog signal into this sampling right here. Now this sampling pulse at this point, at this location. Are you understanding?
Yes, sir.
Right. Okay, now I'm just writing what? I'm writing the sampling pulses onto what is called as the analog signal. Okay, right. Now, what you need to understand here is, so these are called as the sampled signal. Okay, these are called as the sampled signal. Okay, right. Now, please observe very carefully now. Okay, right. Now, this is your analog signal, and to this analog signal, at the time t1, I have given one signal. Okay, I have generated one signal, the amplitude of which is going to be this much. Are you understanding clear? At the time t2, the amplitude of the analog signal is this. Okay. Now, next we have sampled signal now. Okay, this is a sampled signal. Now, next what is that I am going to do? I am having what is called as the process called as sampled and held signal. Okay, and held signal. Okay, right. Now observe carefully. Now I'm just writing again. Okay, so this diagram. Okay, right. So please observe. Now first one is at this point. Okay, so what is the time for this? T1. Then this is T2. Okay, right. Then this is T3. Okay, right. Now please observe carefully. The first one, this is the time signal T1. Correct? Are you understanding? This is the time signal. So this is the amplitude of the analog signal. Okay. I am going to hold, understand this word carefully. I am going to hold the amplitude of this signal up till I am going to get one more sampled signal. Please understand. This is what? This is the amplitude. Okay. I am going to hold it. Hold it means I am not going to increase or I am not going to decrease the signal. I am going to hold this up till where this horizontal line is going to come. I am drawing horizontal line. Can you able to observe? Up till where it is going to be? It is going to be there up till I am going to get one more signal at T2. Now T2 I got the signal. Now I can't go further. Okay. At T2, I have got the another signal. What is the amplitude of T2? Will it's more than the previous or less than the previous?
More than the
More than the then where the line should go? The line should go above or below?
above.
Yeah, the line should go above. Now this goes. Now this is a T2. Now this is the amplitude. This is the amplitude of your T2 signal. Yes or no? Right. Then what is that I am going to do? I am going to hold it again. Hold it up till where? Up till I am going to get one more signal. Okay, I am going to hold it here. Okay, right. Now I am going to stop at this point. Why I am going to stop at this point? Because I have got T3. Then what is that I am going to do now? Will I go above or will I come down? It depends upon the analog signal. Correct? Analog signal is where? Above or below?
Below.
Okay, right. Now I got like this. Okay. Then again, what is that I am going to have now? Okay. Then this is the next signal. Okay. Right. This is the next signal. Okay. Now it is going to be up till here. Then I will go up till here. Then where is the signal? Here. Are you understanding?
Yes,
Okay.
sir.
Right. Now once I have got now I am here. Okay. Right. Now tell me, shall I come below or shall I go above?
Below.
Below. Okay. Up till this signal. Okay. Then again stop. Then again one more signal comes here. Okay. Then like this. Are you getting my point?
Yes,
Okay.
sir.
Now understand carefully. The first diagram, whatever I am drawing here, is a raw analog signal. Okay, a raw analog signal is shown in the first diagram. Okay, so figure A indicates the raw analog signal. Okay, now we have what is called as a clock. A built-in clock is going to be there. The built-in clock generates a regular time signal pulses. Okay, the built-in clock generates the regular time pulses. Those pulses are going to be called as the sampling pulses. Okay. Now these pulses are going to be generated. Okay, generated so as to know the amplitude of the analog signal. Okay, right. Now figure A shows analog signal. Figure B shows what? Shows the sample signal. Okay, at what point you want to know the amplitude. Okay, then this sampling gives, what is the sampling means? Sampling is nothing but it gives a series of pulses. It gives a series of pulses. Okay. Now next is going to be the third diagram is going to be the sampled signal. Okay, the sampled signal, which is the superimposition of figure A and figure B. Okay, so figure A and figure B is superimposed to get what is called as figure C. Okay, then figure D is nothing but, okay, figure D is nothing but we have what is called as a amplitude. I am going to hold the amplitude. Okay, observe, I am going to hold the amplitude till I am going to get, okay, till I am going to get one more signal. Okay, then I will at that time T2, I will observe whether the amplitude is greater than the previous time signal, or lesser than the previous time signal. If it is greater than the previous time signal, then I will take it above. Okay, till I am going to get that amplitude value. Okay, then I am going to hold it again. Holding is nothing but what? Drawing a horizontal line for the pulse till I am going to get one more. Till I am going to get one more pulse. Okay, so this way I am going to convert this analog signal into what is called as a digital signal. Okay, right. Now one more diagram I'll just try to make so that it is it gives much more clarity to you. Okay, right. Now one more diagram, just observe. Okay, so let me consider. This is my analog signal. This is your time. Okay, so this is the amplitude. Okay, right. Figure A indicates what is called as analog signal. Okay, right. Then next. Okay, right. I'll take I'll redraw the same thing. Just please do what is that I am doing now. Okay, same thing, but in a dotted line. Now I am going to take the sample. Okay, the sample is going to be, the time interval is sample S1, S2, S3, S4, okay. Figure B, this is sampled signal. Okay. Now like this, you draw 8 lines. Okay, that is 0, 0, 0. I'll explain this. 0, 0, 1. Over.
Yes, sir.
Is it is it completely done up till here? Have you noted down clearly?
Yes,
Okay,
sir.
right. Now, please listen carefully. Okay, right. Now observe S1. Okay, S1. You take S1 signal and the height of S1 signal, you just try to write the same height onto the below diagram. Okay, now I'm just writing observe. Okay, now one line. In S1, there are two intervals. Now, these two intervals are there. I'm just writing like this. This is one line and this is another line. Is it clear? Okay, right. Then S2. S2 is smaller than that. Correct or what? S2 is smaller than that. Okay. Then first one is a larger line. Second one is smaller line than that. Okay. Third one is still smaller. Okay. Fourth one, somewhere here. Fifth one is too larger. I am just writing on the other side. Is it clear now?
Yes, sir.
Okay. Clear? Shall I explain?
Yes, sir.
Okay, right. Now please listen. Now here, when I am saying that I am converting from analog to digital, okay, so this is going to be your input signal. This is going to be your output signal. Okay, right. What is the form of the output signal that you are obtaining? What is the form of the output signal you are obtaining? It is in the form of digital data. Okay, correct? It is in terms of what? It is in terms of bits. Correct? Okay. Are you understanding?
Yes, sir.
Okay. Bits are obtained in terms of what? Bits are obtained in terms of binary number. Okay. Bits are obtained in terms of binary number with reference to 0 or 1. Yes or no? With reference
Yes,
to
sir.
0 or 1. Yes or no? Right. Now, what is the output of the digital signal? I am having analog signal. I want digital. I am going to convert this analog data into a digital data, which is expressed in terms of what? Digital data is expressed in terms of either 0 or 1. Okay, right. Now observe here. The first one is called as analog signal. Second one is the sample signal. Then the third diagram is called as quantized signal. Okay, just note down quantized signal. QUNTISED. Okay, quantized signal. Okay, right. Now, what do you mean by quantized signal is important. Okay, right. Now, observe. Now, a raw analog, this is the first one is the raw analog signal. Raw analog signal is converted into, the raw analog signal is converted into a series of samples by the process of sampling. Okay, right. Now, the second diagram is called as the sampling process. Each sample, okay, each sample S1, S2, S3, S4, S5 is going to obtain at a particular instant of time T1, T2, T3, T4, and T5. Okay, right. Now, in the sample S1, what is that I am determining? I am determining what is the amplitude at the beginning of the sample and at the end of the sample. Are you understanding? This is the sample, this is the amplitude at the beginning, and this is the amplitude at the end. Okay, right. Therefore, now the amplitude of each sample, okay, right. What is the amplitude of each sample? The amplitude of each sample S1 depends upon the amplitude of the which signal? Amplitude of the analog signal. Okay, amplitude of the analog signal at a particular instant of time. Okay. Now, once these samples are obtained, I am going to quantize. Okay. Now, there is a process called quantization. What do you mean by quantization? Quantization is a process of. Please understand. Quantization is a process of normalizing the amplitude of the samples to its nearest quantization level. Okay. How many quantization levels are present here? How many quantization levels are present here totally? Huh?
7.
I mean number. If you tell me the number, it is 1, 2, 3, 4, 5, 6, 7, 8 quantization levels are present. Okay. Why 8 quantization levels are present? Because I'm expecting the output in terms of how many bits?
8.
Please tell me, please understand. Okay. I am expecting the output in terms of 3 bits. Yes or no? Okay. If I am going to get the output in 3 bits, what are the combination of outputs I am going to get? How many combinations I am going to get?
8.
8. Okay. If I am going to obtain the digital signal in terms of 2 bits, how many combinations I am going to obtain? So either 0, 0, 0, 1, 1, 0, or 1, 1. Yes or no? Okay. Now here, how many bits I want to quantize? I want to quantize for 3 bits. Therefore, how many quantization level is required? Quantization level required is how many?
8, sir.
8. Therefore, now whatever I wrote, horizontal lines are all the quantization level. That is, this one is quantization level 0. Okay, with 0, 0, 0 as the bit. Then 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. Now, we are going to go for quantization. Okay, what do you mean by quantization? Let's take the first one. Okay, S1. S1 as it is I have drawn. So this line is this. Are you understanding? Are you getting my point?
Yes, sir.
Okay, this line is this. The second line is it greater than the previous because of the amplitude? Yes or no?
Yes, sir.
Okay, I wrote here. Okay. Now, the question now is, first line ends here, understanding? Second line ends here. Okay. Now, what is the equivalent? What is the value of digital data for this signal? Okay, it should be between what? It should be either 100 or it should be 101. Are you understanding?
Yes, sir.
Okay, right. Which one should take? 100 or 101 is the question. Okay. Now, whichever the amplitude, which amplitude is very nearer to the nearest quantization level. Now, this is one amplitude, this is another amplitude. Which amplitude is nearer to the quantization level? Which is it 100 or 101 is nearer?
101.
10, are you understand? 101 is nearer. Therefore, what is the data of this? What is the pulse of this? The pulse of this is going to be this one. Okay, means at sample S1, please observe, at sample S1, what is the output is going to be? The output is going to be what? Showing a reading as 101. Are you understanding? Right. Now, second one you come back. Second one. Okay, right. Second one is highest is this. Okay. Then we are going to have this one. Okay, right. Now, this one is very close to this. Therefore, I am going to close this one. What is the signal of? What is the amplitude of this one? Digital amplitude? 1, 0, 0. Okay, right. Okay. Now here you tell me. Okay. In this case, what is the amplitude for the third one?
0, 1, 0.
0, 1, 0. Okay. 0, 1. This is the nearest one. Okay. 0, 1, 0. Okay. Now for this one, for the fourth one,
1, 1, 0.
Okay, now the one which is nearer to the amplitude, 1, 1, 0. Okay. Right. For the fifth one,
1, 1, 1.
1, 1, 1. Okay, right. Now observe what we have done is during the quantization process, we are normalizing the amplitude to the nearest quantization level. Are you understanding? So now here it was somewhere like this. Okay, just observe. Okay, it was somewhere like this. Are you understanding? It was somewhere like this. This is one starting point. This is the end point. Are you understand? This is the starting. Are you understand? This is the starting point. Okay. This is the end point for the same one. Which one to be taken? Okay. Now, whichever which is nearer to. Okay. Whether this is nearer to the quantization level or this is nearer to the quantization level. Accordingly, you match this one. Okay. Or you may match this. Okay. So this is one possibility. Are you understanding? This is one possibility. Other possibility is this. Yes or no? Clear?
So,
This is one possibility. This is another possibility. Okay. If this is nearer to the quantization level, then you are going to get this one. If this amplitude is nearer to the quantization level, you are going to get this point. Okay. So now that is how you are going to convert the analog signal into digital signal. Now you tell me, if I want the exact conversion from analog to digital, is it I need to increase the number of bits or I need to decrease the number of bits?
Increase the number of bits.
Why? What is going to happen if you increase the number of bits? Okay, for 3 bits, how many quantization levels are there?
8.
8. For 4 bits, how many quantization levels you are going to get?
16.
16. Okay, correct. No, 2 to the power of 4. Correct or what? 2 power 4. For 3, it is 2 power 3, 8. For 4, it is going to be 2 to the power of 4, 16. Now, if I am going to have 16 quantization level for the same analog signal, what is that you are going to get now? In between these two lines, are you understanding? In between these two lines, you are going to get what is going to happen to this width between the bits? Is it going to increase or reduce?
Reduce.
Reduce. Okay, now that means totally you will be having 16 number of signals are going to be. That means what? Exact values, exact accuracy you can able to get if you increase the more number of quantization level. Now here, for understanding sake, I took 3 bits. You can take 4 bits. If you take 4 bits, it is going to become 0 0 0 0 0 0 1. Are you understanding? Getting it or what? Like that, it just goes. Okay, that is right from 0 0 0 0, then 0 0 0 1, 0 0 1 0, 0 0 1 1. Like that, it goes further up till where? Up till 1 1 1 1. Okay, totally you will be having 16 quantization levels are going to be there. Okay, you will be having 16 quantization level. Then more accurate will be your digital signals. Okay, now this is the process of what is called as your quantization signal. Okay, or the process of analog to digital conversion. Okay, now next very important thing here is, what is very important is at what time you are going to take the samples. Okay, can you take the sample at any time that you like?
Yes.
Okay, if you take the sample at longer intervals, what is going to happen? If you take the sample at longer intervals, what is going to happen? Any idea? Okay, right. Now just observe. I am having this signal. Okay, right. I will take the sample at this point, and I will take the sample at this point. Okay, only 2 sample. Okay, right. Now, if I convert this into the digital signal, is this digital signal replicates the analog signal? Replicate means it resembles, means is it you have exactly converted analog signal to digital signal if I take sample at these 2 points?
No, sir.
No, sir.
Why? Now, just carefully observe. Here, there is one more thing here. What is this? There is one more signal, which is lesser than these 2. Correct, na? Correct. If you take sample at S1 and S2, is this amplitude are you going to consider or are you going to neglect? Neglect means you're neglected the one which is very important, which is lesser signal. Yes or no? Therefore, what should be the sample? What should be the sampling that you need to make? The sample should be in such a way that it should pick up all the variations of the amplitude. Are you understanding now? Okay. Now, if I take one more here, this also will be taken into consideration. Yes or no? Okay. Therefore, the concept of sampling is very, very important. To use the analog data to your digital circuit, the analog data must be transformed. The analog data must be transformed as it is into a digital signal. Therefore, very important is how are you going to sample or how are you going to sample the analog signal. The process of getting the amplitude of the analog signal is called as sampling. Okay. So what should be the sampling is called as the sampling frequency. Okay. The sampling frequency should be greater than or equal to 2 times the maximum frequency content. Okay, 2 times the maximum frequency content. Okay, now this is what is called as the Shannon's. Okay, Shannon's sampling theorem. Okay, now Shannon sampling theorem. That means the sampling frequency. Okay, now time and frequencies are directly related or inversely related?
Inverse.
Okay, time and frequency are inversely related. Okay, frequency is nothing but cycles per second. Okay, if you take if you take 1 f is equal to 1 over t. Okay. If you take the reverse of your time, it is going to be number of cycles per second. That is called as your frequency. Therefore, the sampling frequency means at what time you need to take. Okay, what is the time gap between the first sample and the second sample? Are you understanding? Very simple. Okay, what is the time gap between the first sample and the second sample? Okay, so that is going to be represented as sampling frequency. That should be, it should be greater than or at least equal to 2 times the maximum frequency content. Okay, now if you are going to take the sample lesser than this, what might happen? If you take the sample lesser than this, what might happen? You may miss out. Okay, you may miss out what is called as an important data. Okay, are you understanding what I am telling? You may miss out an important data, and you end up in getting. Okay, you end up in getting what is called as a false signal. Okay, now to get the real digital signal. Okay, to get the real digital signal. Okay, follow the sampling theorem. Okay, right. Now this sampling theorem, okay, which is present here, has to be followed. Okay, otherwise you end up in taking unnecessary, unwanted data, and you may miss out some of the important data. Like here. Okay, now look here, S1 and S2. Okay, right, you took at this point and at this point, so you have missed out this information. Are you understanding? Therefore, you should take all the information. That process is called as the Shannon's sampling theorem. Okay, right. Now, this is something related to what is called as the analog to digital converter. I'll repeat again. So, analog to digital converter. Okay, you just observe the diagram. What is that I wrote? Okay, right. So, analog to digital converter is basically okay, right. So this is if you observe, okay, this is the analog to digital converter. So you have what is called as the signal, which is going to be like this. This is your analog signal. Okay, analog signal. Okay, now this has to be converted into this digital form. So first to decide whether it is going to be 3 bits or whether it is going to be 4 bits. Okay, if it is 3 bits, you are going to have 8 levels. Okay, if it is 4 bits, you are going to have 16 levels. Okay, right. Then next is going to be, right, the sample. Okay, at what time you are going to sample? Okay, now I am taking the sample at point S1. Okay, so this is my S1. Okay, sample 1. Then it is going to be sample S2. Okay, right. Then it is sample S3. Okay, like this you take the sample to understand what is called as the amplitude of the analog signal. Okay, then now for this you superimpose the analog signal in dotted line. Okay, so that it is easy for you to understand. Okay, right. Then next one, you write the quantization levels. Okay, so totally, as I told, so there are 8 quantization levels are going to be present. The lower one is already marked. Okay, this is 0, 0, 0. Okay, then one more quantization level. Okay, like that you just draw. Okay, right. So this is called as your 0, 0, 1. Like that you go on draw all the quantization level. Okay, so it's the total quantization level. If the output required is 3 bits. Okay, the requirement is 3 bits. I want the data in terms of 3 bits. Therefore, you are going to have totally 8 different quantization levels. Okay, right. For all of them, you just draw one horizontal dotted line. Okay, right. Then after drawing the horizontal dotted line, then write the sampled. Okay, this the previous diagram is there now. The previous diagram you write. Okay, the previous diagram you write on this. Okay, right. Okay, now previous diagram. Okay, now up till here. Okay, right. First one is up till here. Second line is up till here. Okay, right. Now you have this one. This is one amplitude, and this is another amplitude. Okay, right. Out of these 2 amplitude, just observe which is closer. Is it 101 is closer to this, or is it 100 is closer? Okay. Now according to this, so this is the maximum. Now this is 101 is closer. Therefore, what is that you do? The signal is going to become this one. Are you going to understand? The signal is going to become this one. Okay. One more signal. Okay. Right. Now. Okay. First one like this. Okay. This is the signal. Then which is closer? This point is very closer to this. Therefore, you just match this. Okay. Right. This is going to be a 0, 1, 0. The signal of this is going to be 0, 1, 0, which is equal to this. Okay. Now, at this point, at the point S3, at the point S1, the strength, the digital data is going to be 1, 0, 1. Okay. At point S3, the digital data is going to be 0, 1, 0. Okay. Right. At point S5, okay, the digital data is going to be 1, 1, 1. Okay. That means somewhere like this, you are going to get. And next one, okay, it is nearer to the 1, 1, 1. The data is going to be 1, 1, 1. Okay. Now, this is how you have converted the analog data into a digital data. Okay. Now, if you want to increase the accuracy of the digital signal that you got, okay, now I want to increase the accuracy. If I want to increase the accuracy, what I need to do is I need to increase the quantization level. Okay, if I increase the quantization level, what is going to happen? Now, the signal remains the same. The signal remains the same. If I increase the quantization level, I am going to have one more. Okay, I am going to have few more. Please understand, I am going to have few more quantization level. Okay, earlier it was 8. Now I should supposed to get, if I go for 4, I should supposed to get how many?
16.
I should supposed to get 16 now. Okay, what is going to happen? When I am going to draw 16, then you are going to get much more accurate data. Okay, much more accurate, because previous, what is that you are doing? You are normalizing the amplitude to the nearest value. Are you understanding? You are going to normalize the amplitude to the nearest value. Okay, that nearest value may be now divided further. Yes or no? Earlier there is a gap between this and this. Earlier, this is one quantization level, this is another quantization level. Okay. Now the signal was something like this. Okay. Now let me get. Okay, the signal was something like this. Okay, right. Now if I am going to have one more, what is going to happen? Okay, rather than going to this and this, you will find this is going to be the central one, going to be the nearer one. Okay, are you going to get? Right. Then this is going to become much more accurate to represent. Okay, now why we are increasing is in order to make sure to represent the analog signal in the true form. Okay, to represent the analog signal as it is. Okay, accurately, I am going to increase the number of quantization level. Okay, more the quantization level, more accurate going to be your digital data. Okay, now this is something related to what is called the analog to digital converter. Okay, right. So I think we'll stop at this stage. Okay, right. We'll stop at this stage. Then we'll come back in the third hour, and we will discuss the further upon this. Okay, further on this, that is analog to digital converter we are done. Okay, so we'll go with digital to analog converter, and then we'll go for the test discussion. Okay, so third hour I will take half an hour of the class, and maybe 40 minutes I will take. Another 10 minutes we can discuss regarding the test. Okay, right. So we'll stop at this stage, right? So how many of you are there? Okay, 1, 2, 3, 4, 5, 6, 7. Okay, all 7 are present. Okay, right. So I'll stop my presentation here, and we'll meet in the third hour class. Okay, right. Thank you.
Thank you.
Thank you.
Thank you, sir.